Okay, so before we talk about the models, the GM model for building a recommender system, let's first talk about the notation we can use for defining a recommender system. We know that the recommender system can also be represented as a graph. However, for this graph, its structure is very special. It's called a bipartite graph instead, right? So according to the bipartite graph structure, we can define or can provide a notation for the recommender for defining recommender systems, like in this page. So for example, we can still define this recommender system as a graph G covering the sets of nodes and edges, right? So however, for the sets of nodes, we can divide this kind of nodes inside the recommender system into two categories, either users or items, right? Therefore, we can denote this U as a set of users and V as a set of items instead. We also have this link state, this edge state. It covers all the interaction between users and items. This kind of links will be very special. They will be connecting to to nodes of different categories only. So we can represent this E as a set covering U and V. This U will be a user node. This V will be an item instead. So if we have a pair like UV, connecting them inside the recommender system, it indicates that the user U has ever purchased this item V before. So depending on the settings we are starting in the recommender systems, these kinds of edges can be either weighted or unweighted. We know that connecting the user and the items, there will be some edges or some connections, right? All these connections will have different kinds of scores. So to measure the recommendation quality, we can define a score function for the recommendation results. So we want to find the recommendation with the top K scores actually as the recommendation result for the users. So therefore, for each user to get the top K recommendation for the user, we need to have a score function for the user and item interactions. This kinds of measure their quality. So for a user U and also item V, we need to have a real number, a scalar function for measure the score between them and how likely this user will be interested in some items. Also, the key items with the largest scores measured by the score function for each user U, and we can return them as a recommendation result for the user, which is called the top K recommendation. In other words, we define a score function for the recommendation task. So for the top K recommendation, we want to return all the items, top K items the user will be more likely to be interested in as a recommendation result. And we also provide with an example on the right hand side. We know that we have the user set on one side, item set on the other side. For each user, they will be interested in all different items, right? Now from the historical data, we find that this user U has some interaction with the item 5 before, right? The V5. So also according to some score function, for example, we can measure the score for each user and item pairs, U and V0 until V4 as we show here. We can calculate some score for them, right? Now the score for U V0, the pair, the score is 2. For the pair U V1, the score is 3. And for the U V2, the score is negative 2.3. And score for U V3 will be 4, and for the score between U and V4, the score will be 0.7 instead. We find that the score between U and V1 and the score between U and V3, they have higher values, they have higher numbers, right? So according to the score function, we can return this top K recommendation for the user. For all the potential items, the user will be interested in as the V1 and V2 if we set this K to be 2 instead. In other words, we are returning the top 2 recommendations for the user based on the score function we define here. And you can see that this kind of score function is very similar to the linear prediction score. It's very similar to the linear prediction task we studied before, right? We try to measure the correlation between user and items based on their information. And in the following part, we will illustrate how can we learn this kind of recommender systems, and which will be also be slightly different from linear prediction we studied before actually. Okay, so these are the notation we can define for the recommender systems, or the score function we can use for the recommendations. In the following part, we will illustrate how can we define a score function with representation learning inside this GM model.